There was no explosion, no fire, and yet in just a few hours, everything was gone, as a series of small failures slowly turned into something no one could stop. Imagine the safest place in the ocean, a massive steel structure rising above the waves like a floating skyscraper built to withstand the most powerful storms on Earth. It wasn't just a platform, it was an engineering masterpiece designed to survive conditions that could destroy even large ships. The people who worked there trusted it completely. Everything about it suggested control, precision, and safety. Some even compared it to the Titanic, Mike. Not because of its size, but because of the confidence surrounding it. A structure believed to be unsinkable. But on February 14th, 1982, that belief would collapse. Not because of an explosion, not because of fire, but because of a chain of small, overlooked failures that slowly spiraled out of control. Within just a few hours, the largest semi-submersible drilling platform in the world would disappear beneath the North Atlantic, leaving behind one of the most haunting engineering disasters in offshore history. The platform was called Ocean Ranger. Built in Japan in 1976 by Mitsubishi Heavy Industries, it was one of the most advanced offshore drilling rigs of its time. Designed to operate in extreme environments, it represented the cutting edge of offshore engineering. Ocean Ranger measured over 120 meters in length and stood more than 100 meters tall. It had multiple decks, living quarters for the crew, a drilling system, and even a helicopter landing pad. Beneath the surface, large pontoons and 16 ballast tanks controlled its stability. At the center of this system was the ballast control room, a critical space where operators monitored and adjusted the platform's balance. By carefully managing the flow of water in and out of the tanks, they could keep the entire structure level, even in rough seas. In theory, the system worked perfectly. Ocean Ranger had already operated successfully in Alaska, New Jersey, and offshore Ireland before arriving at the Grand Banks of Canada. It was considered reliable, powerful, and more than capable of handling North Atlantic storms. On February 14th, 1982, weather conditions across the North Atlantic began to worsen. A powerful storm system moved into the region, bringing strong winds and rising waves. Forecasts warned of waves up to 11 meters high and winds approaching 90 knots. From the Mobil Oil Office in St. John's, Newfoundland, operators contacted offshore platforms to issue warnings. Ocean Ranger received the message and followed standard procedure. Drilling operations were temporarily suspended and the crew moved into standby mode. For the 84 people on board, this was nothing unusual. Storms were part of the job. The platform had been designed for exactly these conditions, and there was no reason to expect anything beyond a difficult night at sea. At around 8 p.m., a nearby platform, Sedco 706, reported an unusually large wave, significantly higher than expected. It rose more than 20 meters above the surface, striking the structure with immense force. Despite the impact, Sedco 706 remained stable. There were no serious issues. It was a reminder of how powerful the ocean could be, but also a confirmation that these platforms were built to endure. About 30 minutes later, a similar wave reached Ocean Ranger. The platform absorbed the impact without any visible structural damage, and at first, everything seemed completely normal. But inside one of the ballast control columns, something small had changed. A window had been broken. The damage seemed minor at first. The broken window was replaced quickly, and the area was cleaned without much concern as everything appeared routine and well under control. But seawater had already entered the column, and more importantly, it had reached something critical, the ballast control panel. This panel was responsible for managing the flow of water between the ballast tanks. It controlled valves, monitored levels, and maintained the platform's balance. When seawater came into contact with the system, it began to behave unpredictably. Valves started opening and closing without command. Water was being directed into the wrong tanks. Operators quickly realized something was wrong. The platform began to tilt slightly, an early sign that the balance had been disrupted. They attempted to regain control manually, but the system was no longer responding as expected. At one point, attempts to interact with the panel resulted in electrical shock, forcing the crew to step back. The only option left was to shut the system down completely. But even that wasn't simple because the emergency controls were difficult to access, and it took valuable time before the right switch was finally found. By around 9 p.m., the ballast system was shut down, and the situation appeared stable again, as the platform stopped tilting and communication with nearby units continued normally. At this point, it seemed like the problem was under control, but the underlying issue remained as the control panel was still wet and the system had not been properly checked. Later that night, the crew made a decision to restore power to the ballast system in order to correct the imbalance and pump out excess water. What they did not fully realize was that the system was still compromised. As soon as power was restored, the panel began malfunctioning again. Valves opened unexpectedly, directing water into the forward ballast tanks. The platform began to tilt again, this time more noticeably. The crew attempted to counteract the movement using pumps, but the system was already working against them. One of the key issues was that the pump being used was not designed to push water effectively under those conditions. Instead of correcting the imbalance, the situation continued to worsen. Water kept entering the wrong sections of the platform, increasing the tilt. The angle gradually grew, making movement on board more difficult. By around 1 a.m., the tilt had reached a critical point. Communication with shore became urgent. The crew reported that they were losing control of the platform and preparing for evacuation. The situation had escalated from a minor incident to a full emergency in just a few hours. At approximately 1:30 a.m., the final message was sent. The crew stated that they were heading to the lifeboats. Ocean Ranger was equipped with lifeboats designed for harsh conditions. In theory, they provided a safe way to leave the platform, even in rough seas. But the reality was very different, as the platform was now tilted and waves were crashing against the structure with increasing force. Lowering the lifeboats in these conditions became extremely difficult, as some were damaged during deployment while others failed to release properly. The storm made coordination nearly impossible. Visibility was low and the sea was unpredictable. At 3:38 a.m., Ocean Ranger vanished from radar as the platform slowly rolled over and slipped beneath the surface. By morning, the storm was gone and the sea was calm again, as if nothing had ever happened. Search operations began immediately. Helicopters and vessels scanned the area, but only debris and empty lifeboats were found. All 84 people on board were gone. An official investigation began shortly after the incident. It lasted 2 years and revealed a series of critical issues. The platform lacked proper sensors to detect flooding in the ballast system. The control panel was vulnerable to water exposure, and most importantly, the crew had not received sufficient training for this type of emergency. The system itself was complex, and in a high-pressure situation, it became difficult to manage effectively. Following the disaster, major changes were introduced across the offshore industry. Safety standards were improved, training became mandatory, and critical systems were redesigned to reduce complexity. Ocean Ranger became a turning point, a case that showed how even the most advanced technology can fail if small vulnerabilities are ignored. It was not a single catastrophic event that caused the loss, but a chain of small issues that built upon each other. A broken window, water where it should not be, a system that could not be controlled, and a structure once considered one of the safest places in the ocean became a quiet reminder that in extreme environments, even small details can have irreversible consequences